Okay, let's get back. So when you draw ERDA, the most important thing is defining entities and having having correct relationships. Those are important as well. And having the correct attributes is important as well. But one other thing you need to consider is how to allocate entities. So, well, the purpose of the locating and defining locations of entity is reducing the number of crossed relationships. So because we have 3 relationships only, in this case, it is not that hard. But if you have multiple relationships and multiple entities, then how to locate the entities is really important. Let me give you an example like this. So if I place book title here, it looks like there is a relationship between two relationships between book copy and patron, right? And it seems like there are 2 relationships between book copies and book title, although there is only one. So if you locate book title here, then you can easily, you don't need to be understood, right? But if you locate copy here or book title, book copies between patron book title, your audience or readers of your ERD may be understood. So it is also important to locate find the proper location of entities, because you can change the location of entities using these applications, but your leaders cannot locate because you have to print or export as a PDF or as a report. They will see non-dynamic ERDs. They only see printed one only. So that is what I want to emphasize again. Okay, so let's go to, well, the later part of chapter 3 about details of subtype and supertype. So if I have more time after covering chapter 4, I'm going to revisit, but I don't think I have time to revisit the later part of chapter 3. So I hope you guys read chapter 3 and understand by yourself for this case for now, because after this week, you will have an exam, right? Okay, so let me go to chapter 4. Chapter 4 is how to normalize logical design. So normalizing is mental process to convert logical model to relational model. Some applications like data modeler can easily convert logical model to relational model. Especially it removes all awkward aspect of relationships, but it doesn't normalize attributes. So you have to understand how to normalize, and which contains normalizing attributes and normalizing relationships. And normalizing is removing anomalies. There are several types of 3 types of anomalies: insertion anomalies, deletion anomalies, and modification anomalies. So to remove anomalies, you are required to do normalize, but normalize is not a simple process. Depending on the situation, you may need to normalize up to 4th normal form, including voice count. But there's another tip to easily normalize unnormalized relational logical model to relational model. And this textbook utilize EER notation as a milestone to normalize. So let me go to EER notation first. In relational model, some terminologies are transited. For instance, entity, still entity, but relation also indicate entity as well. And now tables also indicate entities. So relation and tables are corresponding terminology in logical design. The reason is you have to expect in your entity, you have to expect data will be added or modified in your entity. In logical design, we need to, sometimes we do, but you don't need to consider what data will be stored. But in relational model, you have to think what data will be expected to be, you have to expect what data will be added or how the data will be modified. And another reason why relation and tables are corresponding terminology is format of data in the relation. We have two axes, rows and columns. As long as data format in rows and columns, we have to consider that as a table, right? Or tabularized form. And rows in entity are instances or observation or examples. Columns correspond to attributes, which means these columns shown vertically, right, in logical design, but still will be represented, columns as represented vertically, but you have to think attributes eventually will be converted to columns, which means will be located horizontally, not vertically any longer. So this is a EER notation. Some textbooks don't even explain EER notation, but this textbook utilize EER notation. The reason is it is intermediate form of table, which is final form from logical design. For instance, okay, if we had, we don't have, okay, here. If we have customer entity, this entity is transformed like this in EER notation. The attributes are written vertically, but columns or attributes in EER notation shown horizontally using separated cells. But by having this format, we can easily expect what data will be added in customer relation. There must be customer ID under customer ID column. Customer name should be located below customer name heading column. But in this model, I know how and what data will be added, but as a newbie or beginner, sometimes it is hard to imagine what data will be added. But as long as you are familiar with Excel spreadsheet or any types of table, we can easily expect what data will be added, how data will be added. Okay, what about this? Customer ID is much easier. Customer ID will be below customer ID column, customer names, extra customer names like Jim Ryan or Jack Jordan will be added under customer name, and their addresses will be added under customer address column. I'm not saying this is well normalized form, but anyway, we can easily expect. So when you have entities in logical design like this, first step to normalize, according to this textbook, is converting logical ERD to EER notation like this. In EER notation, you have single row which contains attributes or columns. So using Excel spreadsheet, it is easier to draw EER notation. All right, so let me use Excel spreadsheet. And I will select title. Not this one. Okay, let me stick the library case. Okay. Okay, let's start with the easier one, book copies and book title. Book title in ER notation. First, you need to write the name of entity or relation or table on the top of cells. And here, title number must be located at the first cell, then title, author, publisher. And as textbook did, I will add borders. Okay, so far good. But you have to show which column is primary key. If it is primary key, you can add underline. So by seeing underline in this column, everyone can see catalog number is the primary key. Book copy. So book copy, copy number, edition, year, ISBN, book status. Okay, copy number is primary key, right? So book title was easier to convert to year notation. But when you convert book copy, there's some attribute you shouldn't forget. Which one was that? Catalog. Yes, right. Catalog number. In logical design, catalog number is not shown, although we selected catalog number as a primary key. Combination of catalog number and copy number is a primary key. So which means you must have catalog number. That's the distinguished feature of EER notation or relational model. The catalog number and book copy are primary key or composite primary key. And we have to make sure catalog number refers catalog number in book title by drawing a line. Okay. chart illustrate. Let me maximize the window because I want to see design. Where is the line? Oh, shape here. Okay. If you prefer curved line, it's up to you. So by having arrow, we can easily figure out catalog number of book copy refers catalog number of book title. Okay. What about patrons? Or subtypes? We have to start from patrons first. Patron ID, name, address, telephone, and patron ID is primary key. So let me add underline. And if you have subtype, you have to have all different subtypes in ER notation. Undergraduate. Okay. Program. Order. Ready. Oh. Is that all?
When we need to add patron ID to undergraduate?
Yes, we need to have patron ID. So by having same patron ID in patron relation and undergraduate relation, this undergrad student can use information of name, address, telephone number with the same patron ID. So let me add patron ID and I will add borders. Obviously, we need to add arrow. Okay.
Dr. Bain, for undergraduate, wouldn't we also add another unique identifier like undergraduate ID? Maybe for, I don't know.
As long as, well, it depends on your original design. If you have, well, it is okay. It is okay. But if you allow undergraduate students have their own ID, then you have to add primary key here or prior to program name.
But we don't have any other entity, right? Like which associates the undergraduate. So
yeah, in my design we don't have. So that's why I don't have a primary key for distinguished primary key for undergraduate or any subtypes. But if your design have the primary key, then yeah, you have to add. And if you have the distinguished ID, it is correct as well. Your model is correct as well. So if you want to, it depends on your assumption. Your design is always based upon your assumption because the given situation doesn't deliver the exact information. The information is here not enough at all. So let me give you an example. The book copy, book title, it is one too many, right? And the reason I have mandatory one too many between book title and book copy is my assumption is without book copy, we don't need to maintain book title because I thought the library is sole library in a campus. But if the library connects the other libraries in other campuses, like Urban University and Urban University Montgomery, then book title can be maintained without actual book copies. In this case, yes, in this case, target is book copy. So you have to select optional for book copy. So if you have optional many, book title information can be maintained with the book copy. Okay. What about this case? I can't even imagine the relationship, but I can explain using another example. Okay, so okay, let's think about this case, customers and orders. If your target popular marketplaces like Amazon or eBay, customers needs to sign up first to buy certain items, right? But by having optional here, customers simply sign up without purchasing any order. But some online shopping mall by manufacturers like HP or Dell, they sell their products directly to their customers. Recently, I purchased a PC desktop from HP. I haven't signed up HP online shopping mall before I purchased. But anyway, I purchased a computer without signing, without creating my account. But I decided to creating my account because I want to receive these days, because logistic disaster, many of manufacturers takes a lot of days to assemble desktop. And they said the product will be assembled within 2 months. It's really long time, right? So I want to keep receiving status of my order. And also I wanted to receive tracking information. So in this case, if certain shopping mall allows to buy products with us creating their accounts, it must be optional for both sides, right? But for our library case, my assumption was without book copy, we didn't need to maintain book title information. That was my assumption. And without book title, book copy information cannot be maintained. That is my assumption. So if you want to add your assumption, then you're always welcome to add. How? Note. By adding new note. Library doesn't maintain book title information without purchasing a or multiple book copies. That is my assumption. Okay. So by having note, you can strengthen your argument. You can strengthen your model. Okay. So when you turn in your assignment or when you design your ERD, you always recommend you to have notes to show your assumption, which is not clarified in description or questions. Okay, so let me go to graduate. Okay, well, graduate. What was that? Oh, I'm sorry. Graduate program. And advisor. patron ID. So just like undergraduate, you need to maintain relationship between patron and graduate. And what else?
Faculty, yeah.
Mhm. Office address. Office telephone number. Well, I should expand the cells with, but okay, let me expand. Okay, so okay, so that is good enough. But if you want to make a better model, EER model, when you have super type, it's better to have type. Okay. So by having type, you don't need to look at, or database don't need to look at all three or subtypes under patron. If you specify type, database need to look at only one subtype, which reduces scan time. Okay, so we are done by subtype and supertype. Okay, so now if we keep using the many-to-many relationship between patron, book copy, patron, and book title, we have to draw double arrow line style. Let me just select this one. So book copy, if we just follow many-to-many relationship, we have to draw a line between book copy, catalog number, and patron ID, and copy number, and patron ID. Okay, looks like okay, but to refer patron ID from catalog number, we have to add patron ID just like we added here and or here, which means unrelated information, which is patron ID, should be maintained in book title and book copy. It doesn't make sense. It must be about book title or book copy. So if there is many-to-many relationship, just like we added intermediate or bridge entity or associative entity, we have to add additional relation. So although we don't see associative entity between patron book copy and nor patron book title, we must add intermediate relation when we draw ER notation. So loan reservation in loan, obviously we need to add 4 attributes. date, loan, loan status. Okay, so loan, I think we don't need to have loan status because we have book status. So by looking at book status, we can check out which book is rented, which book is not rented. So maybe it's better to delete. Loan must be modified. Loan period. Loan interest. Okay, so yes, right. That's right. That is what I want to tell you. So loan itself, these three columns have contains enough information about loan itself, but it missing very important information because loan without book copy number and without patron ID, we cannot fulfill loan, right? So we must add foreign key or reference from patron. What about book copy? These two are used primary key, which means without having those two attributes or columns, we cannot completely keep the record about loan information. So I should explain reservation first, but anyway. Copy number, roll number. So let me remove this unnecessary line. Copy number. Refers copy number and catalog number. Refers catalog number of book copy. So eventually this catalog number will refer book title. Reservation. Date reserved. Priority and date fulfilled. And just like loan, we must maintain patron ID and book catalog number. Okay, so far so good. But there's still something missing, something we didn't complete yet.
To track pattern ID also.
Patron ID for reservation or which one?
Pattern ID we did not.
Oh, right. Yes, right. It needs to. Catalog number needs to refer here. Right. patron ID. And here, right? And catalog number, yeah, reverse catalog number. So by having references, by defining all references, our ER notation is completed. So the distinguish the major differences between ER notation and ERD is we have to use single row to represent attributes, right? And we have to add all missing references, which is not shown in logical design. That is important thing. But the reason is, although this SQL developer, this data modeler can automatically add references when you convert this one to relational model, but many of other applications doesn't support the function. So now I'm going to show you how to convert this logical design to relational design. We have nothing yet, right? We have a relational model, but we have logical model, but we don't have a relational model yet. Then do we need to? So let's compare the icons. When you select logical tab, let me close all of them. Okay. So when you select logical tab, you can see yellow icons and green arrows. But if you select relational tab, then it is changed to tables. If you move your mouse cursor over, then it is not entity, but it is table, right? Table is the same, exactly same with relation. And you had relation types 4 or 5, but you don't have. You have foreign key only. So those two models are similar, but terminologies are different. The reason why terminology is different is you need to draw a slightly different model. How? Do we need to draw it again by referring those diagrams, this diagram? Not really. Let me show you. Go to File, and okay. You don't need to go to File. Select logical model and hit right button, and you will see menu items, and select Engineer to Relational Model. Then you will be asked what will be transferred or converted. Just select Engineer. Select everything and Engineer. Then now you have relational design. Okay. So I'm trying to allocate as similar as I can. So I have patrons here and book copy here, and I have loan between patron and book copy, and book title, reservation, and patron. And I have 3 different types, subtypes. And it uses slightly different shape, but anyway, you use half circle. I call it half circle, but it doesn't have individual half circle. It covers all subtypes unlike the textbook. In the textbook, there are individual circle on the relationship, but in this application, it covers all subtypes. So if you look at some ERD outputs by different applications, you should be able to interpret, or you should be understand. You have to understand. You don't need to. Sometimes you cannot draw because you don't have full idea about certain applications, but at least you should be able to interpret. Okay, so that is how to convert it. Okay, and if you convert, you will see additional informations. See, for instance, in loan, let me go to patron. Patron ID has shop at left, which indicates patron ID is primary key, but in relational model, primary key or unique identifier is defined in another column. Although there's P here, P indicates primary key. Okay. Book title, P is here, which means book catalog number is primary key or identifier. But if you look at book copy, now we didn't see catalog number in book copy. We only can see copy number as a primary key. But if you go to the relational model, now you can see copy number and book title. So first, prefix indicates the source of the reference. Book title, catalog number came from or refer catalog number at book title relation. And unlike copy number, you can see P and F. P still indicates that is primary key, and F, yes, refers foreign key or reference. It refers, catalog number refers catalog number at book title relation. Okay, and it has two additional information. Copy, book copy PK and book copy FK. We're going to look at what this indicates later when we need to when we study DDL after first exam. Okay, so what about, well, reservation or loan? It's more complicated, right? In logical design, we had many-to-many relationships only. Although we had some attributes, we only defined additional attributes only in logical design, but relation design, we have, well, basically we have three attributes and we have primary key and foreign key. Okay. We can see hidden foreign key and primary key in loan and reservation relation. Then you may ask, okay, so it is possible to, by using SQL modeler, we can automatically convert many-to-many relationships to one-to-many with bridge entities. Then why we need to keep using, why we can't using many-to-many relationship in our logical design? You can use it, but eventually you need to convert. Luckily, this application supports many-to-many relationships to one-to-many, but it doesn't mean the other applications also support similar functions. Many of cases it doesn't support. So you have to practice yourself not to draw any many-to-many relationship, even though you're using SQL data model. So I'm going to show, I'm going to add two more attributes, entities.
Dr. Bain, I have a question.
Mhm,
From the relational model,
mhm.
does it provide the capability to re-engineer this tool? Like, since you're going to add two new attributes to the logical model,
Yes, it is
if you
possible.
so you can't add two new fields here and then it
Yes.
re-engineers back,
Mhm.
reverse back. Okay.
Yes, whenever you draw new logical model, you always can engineer to relational model. Also, it is possible to engineer from relational model to logical model as well. But sometimes when you engineer, this application is not perfect. So sometimes your design, your original design may be messed up. So relatively, engineer from logical to relation is much better than from relational to logical. So I recommend to draw logical design first and then engineer to relational model. Okay, so let me go back to logical. Yes, it is possible. Let me show you. If you hit right button, you have to, yeah, so make sure. It is possible to logical model. It is possible logical from logical to relational and vice versa. But I wouldn't do that because I'm worrying about messing my original logical design. Okay, let me add. So what I will do is having rent entity, and I will define same. I will define relationship between patron and rent and book copy, but I will leave the original relationship because I want to show you what's different. What differences are found when we engineer or convert logical model to relational model. But anyway, there's optional many-to-many, which means there should be men3 1 to optional many from patron and rent. Okay, and so I defined entity and two relationships, and I will remember the original relationship name was loan and new one is rent. So I'm going to engineer to relation model. Then you can see two entities between patron and book copy, right? So what's benefit? Let me double click. So there's no way to define as primary key from these attributes, which means this relationship is heavily depends on patron and book copy. But if you have independent bridge entity, you can define your own primary UID. So what that means, let me show you again. What that means, you will have rent ID as a primary key, but still you have patron ID, book copy number, title number as a foreign key. What's the benefit in this case?
I guess as you get more detail, you can.
Yes, all details, right?
You can get the records, rent records, which are not there in either
Mhm.
pattern or copy.
Yeah, okay, yes, right. Right. What if you want to, so if you see the description, then you can get some ideas that DBA wants to track the habits or history of rent loan. But what if book copy is not available any longer for some reason, like burned or lost, any reasons? In this case, you may want to delete book copy ID because you don't have the book, your library doesn't have book copy any longer. And if book copy isn't in the table, then the other patrons may think the book copy is still available. For this case, you may want to delete the book copy information from the table. Or what if patrons is graduate so that the patrons are not eligible to borrow any book? You may want to delete the record, right? So if you delete patron information, then how can you maintain existing loan or rent information? Do you need to delete loan by the patron or not?
Yeah, if the patron is going to be deleted, I mean, all those things are associated to it. So you can't delete patron if you have all these sub
Yes, right.
locations.
Yes. So it depends on your policy. You may have a little, well, if you have this primary key, then if your library changes policies, even though, let's say, we didn't maintain graduated graduate any longer, or if faculty retires, they are not possible to borrow any book. So we have to delete all into history. But new librarian wants to keep the record, even though patrons are not eligible any longer, because by looking at their history, the library can offer optimized rental service for the next or new coming patrons. So if you maintain this way, it is no way, because as patron information deleted, loans related to patron must be deleted as well. But if you have different one, patron ID is not primary key any longer. So rental or loan information can be maintained without existence of patron or book copy. So this is very common in online shopping mall. Let me open the example here again. So customers can place many orders, and more orders can customers can place many orders. So let's say customers can simply easily create their account or asking delete their account. But customers' order history is very useful, very valuable information for online shopping mall, because they maintained customers' profile such as age, location, or education level, or income. So by comparing customer groups, although customer information is already deleted, by comparing customer groups, you can generate recommended items for the similar customers. But without order information, the online shopping mall can't make any advanced service. But if order is strongly associated with customers, if customer wants to delete their information, all related order information must be deleted, because order information cannot refer any customer information. See? where is it? Where is it? Here. If customer ID, like patron ID, is primary key, without existing patron ID, loan information must be deleted. At the same time, patron information is deleted. But if it is simply foreign key without patron ID, rent information can be maintained because we have independent primary key. Okay. That is the difference. So which one's better? Depends on situation. Depends on situation. Okay. In this case, it is, well, seems like it's better to have independent primary key for rent. But what about reservation? Seems like it is less important to have independent primary key because if patron decide to retire or decide to graduate, the existing reservation doesn't need to be fulfilled because they are not eligible to borrow book. So you have to see the differences, and you can always add your assumption. But what is important is you have to consider every single possible cases in the relation, and to check out every single different possibilities. If you just look at this entity, you cannot you're hard to imagine the case. But if you convert ER notation, mentally and cognitively, it makes you easier to think the different cases. Okay. Question so far? Okay, let me save this file. And I will save to exercise library ER notation. And that is what covered at the first half of chapter 4. So, well, this text will use the disconnect line to indicate this foreign key, but there's no way to have disconnected on the line in Excel. So by having the arrow, we can easily know the starting point of arrow does refer column where this arrow ends. Okay, so it is okay not to have any any disconnected on the line to indicate that refers this one. But if Excel supports disconnected on the line, then it's better to have. Or if you really want to maintain the similar thing in Excel spreadsheet, it supports double underline. Okay, so if by having double underlines here, you can give more detailed information. These two columns refers these two, but you have to know, you have to add your own note. Single underline refers primary key, and double underlines refers foreign key. Or just like notes in SQL modeler, you can add a text box. So again, note is always welcomed. Always welcome. You can add your own assumption without limitation, as long as you're learning in this course. And also, it is also recommended when you need to design real ERD as well, because by having notes, your audience can your notes can guide your audience to interpret your ERD correctly without misunderstanding. But in this case, as long as you add certain notes regarding foreign key and primary key, you need to keep using double underline. Okay. For consistency of your design. Okay, so and eventually this EER notation will be used to define relational model, and the relational model will and normalized relational model will be used to generate or to produce codes of DDLs like this. But we are going to learn DDL in chapter, I think five or six. Okay, so anyway, we'll still passing milestone from logical design to physical tables, and relational model is intermediate step between logical and physical table, and there is ER notation between logical design and relational design. Okay, so we learned how to represent one-to-many and many-to-many, one-to-one and one-to-many. In many-to-many case, we need to create new relation, just like we added associate entity in our logical model. So it is better to have intermediate or associative entity, even though you draw logical design, because by having associative entity, you can control your design. You can control better without having associative entity. We can modify the primary key if you just simply use many-to-many. Okay, so and this is many-to-many. So in this case, by considering the attributes of relationships, we must create intermediate or a new relation between many-to-many relationships. All right, so on Thursday, we're going to practice normalization. And normalization, we'll practice up to, first, we're going to look at the purpose of normalization and how to normalize unnormalized relational model. Question?
I have a couple questions, Dr. Bain. My first question is, when you're designing your tables, is it a bad practice to just basically put a unique identifier on each particular table you create? I mean, instead of creating like composite keys and all that, just create a unique identifier for every specific table you create in the repository.
There is no one right answer. Sometimes it's better to use composite primary key, or sometimes better to use single primary key. But I prefer to use single primary key, because if certain member of primary key is not possible, for instance, well, the examples in chapter 2 of composite primary key is flight. You should be flight. Anyway, flight and time. Those two attributes are used as primary key. But what if the flight itself is not available? For instance, for maintenance purpose, some flights should be go to maintenance facility to be fixed for some reason, or date was modified, date was changed, or time is changed. Delay, you can see a lot of delays in airport. It is very common. And if it's primary key, then you have to modify primary key value. But modifying primary key should be very careful. The reason is when you modify primary key, you have to make sure if there is no duplicated value. And some tables, some database may not allow to modify primary key value itself. So even though it is possible, it is fully possible to define flight ID, a flight number and date or hour as a composite primary key. If you have any possibility to modify primary key itself, primary key values, then it's better to not to use composite attribute as a primary key. So, well, if I simply say, I prefer to use single primary key instead of composite primary key. The composite primary key is a concept, but in industry, it's hard to find the case.
Gotcha,
Okay.
thank you. And I have one last question.
Mhm.
If you're using, for example, with primary keys, from your experience, do you prefer to use a GUID ID or integer for a primary key for the actual primary key value itself? You know, when you identify the
Mm.
type, you can identify it as an integer, or you can also identify it as a GUID. So I'm asking, like, what's your preference, to use a GUID or just use a basic integer for primary key?
Uh, can you repeat your question again? So when you define primary key,
Yes, normally there's like two different ways you can put primary keys on tables. Like some repositories you can use what they call a GUID ID, a GUID,
mhm,
or you can use
number,
just a basic, like a basic number or integer to do it. So I was just trying to see
well,
what was your suggestion to use.
it really depends on, well, I guess it is, there's no right or answer for this case. Although I have some preferences on composite or single, but I don't have any preference. So it really depends on policy of institution. For instance, uh, is it called SID or S number which indicates student identifier? Is it SID or S number at AUM campus?
Society.
SID, yes. If it's preferred in the institution, you can just use ID. But sometimes numbers preferred as well. So it really depends on. For instance, I have 3 unique identifier as employee: banner ID, employee number. I forgot the other things. But anyway, ID and number are used for one employee, even in AUM, and across urban campuses. So it really depends on. If you prefer to use number, then you can use. If you prefer ID, then it's up to you. And I think it depends on what other nouns are added or attached. For instance, for zip, we are it's better to pronounce zip code instead of zip ID. But if zip ID is more frequently used in some countries, then they may prefer zip ID instead of zip code. Or postal ID, postal code. Well, postal code is better. Looks like looks better for this case. But student ID, employee ID, customer ID. In the case, ID seems better. Did I answer good enough?
Yes, sir. I got your point on that.
Mhm.
I know sometimes, like in our shop, we use for certain projects we use a good ID, which is sort of
Mm.
like an elongated
Mm.
like hex number. You know, just
Mm.
it's an algorithm that generates it, and then you can also use of course an ID by using the sequencer on it
Mm.
to increase it. So I was just trying to see what was the preference, but again, I think from what you're saying is it just depends on policy, and then
Yes, right.
yeah, so it makes sense.
Mm. Or one thing that I can add, the attribute type for primary key is if the primary key can be manually interpreted, you must use string type or character type instead of a number, even though it may look like number. But if the ID or identifier is generated by the machine, it's better to use number, because using increment function, some unique identifier should be generated by the database or program which access the database. Okay, let me give some example. Korean social security number, because I don't have enough idea of what this number indicated by social security number. Well, okay, social security number format. Well, we can simply Google. But anyway, in Korean social security number, first 6 digit number indicates date of birth. Okay, so for instance, October 1st, 2001 dash. Okay, so this is my example. First 8 digit number indicates date of birth, and the first 4 digit number of the second half part indicates local code, like zip, but they have slightly different zip code. All the Korea use 6 digit number as a zip code. And what is the last 3 digit number indicates? It indicates the order of birth of the same date. So if a person have this social security number in South Korea, the person was born October 1st, 2001, and the person was born in 1006 code area, and there were 117 babies born earlier than the person. Okay, so in this case, we cannot use number because we have dash. Even though we don't have a dash here, its digit number has its own meaning. We cannot define these identifier as number. The reason is simple. What if baby was born September, not October or August? Most of the system automatically cuts first this number. If the first this number is 0, right? And because the total length doesn't match with the other identifier, this number cannot be interpreted. So to keep 0 for some cases, even though it looked like number, it must be formatted as string or character type. Okay, and if there is dash, it's much more easier to figure out, like this. Because with dash to represent dash or any symbols, numbers, we cannot use number. Only the string is possible format or character type, attribute type to contain dash and number. Okay, I think the social security number of US has its own meaning as well. Let me take a look at it. I said SN. Yes, if you look at some documents in Google, yeah, first 3 digit number indicates area number, group number. I don't know what group number means. The serial number, which means the order of sort of application for Social Security number. So let's say if my last 3 digit number is 0001, that means I was a person who applied first Social Security number in the same area. Okay, so well, it has, as you can see, area code is slightly different. It is not area code for phone number. They have their own area codes. Alabama is 416 to 424. Indiana, Iowa, they have their own area codes. It's not 334, right? So I don't know what group number indicates. But anyway, like this, if certain this number or certain positions indicate some meaning, then you must use string type ID or number. So maybe if it is identified as a pure number, then you may call it, or you may name the primary key as number, or if the primary key is not pure number, then it's better to use ID. But still, it depends on your policy. Okay, so any other question?
Good evening, Dr. Bang.
Hi.
A student asked a question in the chat regarding the due date of the assignment for the discussion. Will you provide additional clarification regarding the due dates of the discussion post?
Yes. So originally, all discussions, students need to post their original posting by Wednesday, and then so that students can leave comments by Friday, and students can respond their comments or on their original posting by next Monday. But I think it is too, if I mandate to initiate posting by Wednesday, which is tomorrow, students won't have enough time. So I will ask you to post your initial posting by Thursday night. So, okay, so is it enough?
Yes, sir. Thank you so much.
Okay, my pleasure. So original posting by Thursday, comments by Friday, and response by Monday. Okay. So any other question? Yeah, thank you for asking. Almost forgot. Okay, so any comment or question? All right, so maybe it's time to dismiss. It's time to call it a day, although it is almost 10 o'clock. So I hope you guys drive safe, and I will see you guys Thursday. And this video will be posted as soon as I receive the confirmation email from Zoom. Okay, thank you for joining this class. Then I will see you Thursday.
Yes, sir. Have a good night, Dr. Bang.
Thank you, sir. Good night, sir.
Good night.